This is the actual surface of Mars. Very cold and silent, almost motionless. But that's only at first glance. And these are the data and photographs obtained directly from the surface of the planet. A view from the surface of Mars from the rover's own cameras. Real panoramas and images of the red plain of Utopia taken by Zhurong right after landing and while moving. Tracks of the rover and its movement to the south. High rise clearly shows the white bright tracks from Zhurong's wheels leading away from the platform. These photos are 100% real. Selfies and ground shots from the CNSA, Tianwen-1 and Zhurong cameras. Orbital images from NASA's high-rise. And this is the epic selfie that Junjun took himself. He drove 10 meters away, dropped a wireless camera, came back, and stood next to the platform. The first family portrait like this on Mars. And now, here's something interesting. If you slightly increase the brightness on NASA and CNSA's orbital images, you can clearly see a small crater under the landing platform, scorched by the flame of the main rocket engine. Here's the shot. And here's how it looks from orbit, NASA's high-rise. The Chinese used this landing scheme on Mars for the first time. And the engine kept running even after touching the surface. It didn't shut off instantly. It kept running for a few more seconds to completely eliminate the remaining speed and to firmly press the 240-kilogram platform to the ground. Because of this, the flame literally melted a small crater into the Martian regolith. This is exactly the video that was captured near Mars's orbit. There, you can clearly see the polar cap on Mars's surface. And here are some more incredibly stunning shots of the parachute opening. These video cameras were installed so that later we could visually observe exactly how these elements work in the atmosphere. In fact, it's a dynamic, complex world with a history that may have included water, an atmosphere, and conditions that are somewhat reminiscent of those on Earth. And it was in 2021 that a new player confidently entered the scene: the Chinese, China, 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 China. The Tianwen-1 mission was China's first attempt in history to reach Mars. And immediately there was incredible data about the surface. Very realistic. It looked as if it was the surface of our planet. But this is Mars. To understand the scale of this achievement, let's go back a little. In 1971, the USSR sent the Mars 3 spacecraft. It reached the surface, but just a few seconds later, the connection was lost. No data.
Никаких результатов?
Only the fact that it landed. Later, in 2003, the European mission with the Beagle 2 lander tried again, and again, silence. Only years later did it become clear. The spacecraft landed, but it couldn't fully deploy. Communication was impossible. And this is where a fundamentally different story begins. On July 23, 2020, a heavy rocket launches from Earth. On board is a highly complex interplanetary system. That's not true, it's a probe. It's an orbiter, a lander, and the Mars rover Zhurong. For the next 7 months, there is only the silence of space. Almost 500 million kilometers of travel, trajectory corrections, absolute precision, and here is Mars. But arrival is only the beginning. The spacecraft is in no hurry to land. For 3 months, it studies the planet from orbit. It scans. It analyzes. It compares. In the end, the choice falls on the Utopia plain. It's a huge flat region. It's relatively safe and possibly once covered by water. Next comes the most dangerous stage of the entire mission, atmospheric entry. The speed is about 18,000 kilometers per hour. Mistakes are not an option. Events are unfolding rapidly. Atmospheric compression, heating, deceleration, parachute, heat shield separation, and then engines. The final descent. Soft landing. In these images, you can see that all the solar panels and the rover's antenna have deployed as intended. The image confirms the successful deployment of the descent ramp. In this state, the rover spent more than a week taking photos and checking its systems. The Chinese team created a model of the platform and its surroundings to make sure the rover wouldn't tip over during descent. The device weighs 240 kilograms, and it's impossible to turn over such a machine. But here too, China chooses an unconventional solution. Instead of complex suspension systems, there's a platform and a ramp. The rover isn't dropped, it carefully rolls down. Simple, rational, reliable. The first days are slow, very slow. The connection with Earth is only about 16 kilobytes per second. Every snapshot means waiting. Every command is a risk. That's why the rover doesn't rush. It analyzes, checks, and compares. Here it is. The Chinese Mars rover Zhurong and its landing platform, captured from Mars orbit. These images were taken by the high-rise cameras aboard a NASA spacecraft. And now movement. The first descent. The first mark on the surface. The speed is about 10 meters per day. Slowly? Yes, but that's exactly how real science works. Then something unusual happens. The Mars rover takes a picture of itself. Not with a built-in camera, but with a separate device. It leaves the camera, moves away, takes a picture, and comes back. It's not just a shot. It's a demonstration of the mission's engineering capabilities. Next, research. Systematic and consistent. The Mars rover is moving toward the parachute landing site, toward the dunes, toward new geological structures. But Mars is not just its surface. There are also conditions that make things difficult. For example, the sun. When it is between the Earth and Mars, the connection almost disappears. The Mars rover goes to sleep. It waits. And then it continues. And it brings the main discovery of the mission. Hydrated minerals were found in the soil. This means there was water, and possibly not only in the distant past. There are probably still traces of it beneath the surface. And this is where it becomes clear. This is no longer just a mission. This is a systematic study of the planet. Originally designed for 90 days, the rover has continued to operate for over a year. Almost 2 kilometers of travel, hundreds of gigabytes of data, dozens of experiments, and now the coolest part. Independent confirmation from NASA. The American Mars Reconnaissance Orbiter spacecraft once photographed the landing site from orbit. In these high-resolution images, you can clearly see The landing platform. The rover appears as a small dot just to the south, long tracks from the wheels. The parachute in the back part of the capsule. A dark spot of scorched ground under the platform from the rocket engines. Compare before and after. Before landing, a clean plane. Afterwards, there are bright traces, clear landing sites, and white stripes from the maneuvering engines. NASA even noted that the site became noticeably darker due to the dust being blown away during landing. The rover specifically drove to the parachute landing site to study it. The Chinese wanted to find out if it would interfere with future missions. And then it moved on through the sand dunes, traveling about 10 meters per day. Here's the actual view of the surface at the landing site. Utopia Planitia. Once there was probably an ancient sea here. Scientists see traces of shorelines and waves. And at some point it becomes obvious. Mars no longer belongs to just one country. Exploration has become global. The Tianwen-1 mission changed the balance. Not with fanfare, not for show, but fundamentally. And perhaps it is from this moment that a new era begins. An era in which humanity explores other worlds not alone, but together.